Welcome back. I am Mr. Fuller, and this is a lesson from Chapter 1, Section 9, Patterns, Equations, and Graphs. To begin with, let's review a couple of vocabulary words that we should already know. We're supposed to draw a line from each pair of numbers in column A to its description in column B. So if you look at the two descriptions in column B, one of them is opposites, or additive inverses, and the other one is reciprocals. So as we think about what those words mean, let's see if we can connect each item in column A to its definition in column B. So 5 over 6 and negative 5 over 6. Are those opposites or reciprocals? Well, you probably remember reciprocals turns the fraction upside down, and this is not upside down. So these are examples. These two fractions are opposites of each other. So let's draw a line connecting those. 3/4 and 4/3, on the other hand, that's a classic example of the definition of reciprocals, where each one is the other one flipped over. So let's draw a line connecting those. Now, the last set is a little bit more confusing. -2 and -1/2. Well, you know, they're clearly not opposites. They're both negative. So reciprocals is going to have to be the way to go. But why are they reciprocals? Well, stop and think about it. If you took 1/2 and you flipped it over to make the reciprocal, wouldn't that make 2 over 1? And 2 over 1 is 2. So -1/2 and -2 is the same example, just made negative. 1/2 made in, if you made the reciprocal of 1/2, you would get +2. If you made the reciprocal of -1/2, you would get -2. Now we have some new vocabulary for this lesson. Inductive reasoning. The definition of inductive reasoning is the process of reaching a conclusion based on an observed pattern. So basically we can take a set of values like a table and follow the pattern to make a prediction for a missing value. What's the rule? How do we find the next number? So that's the main idea, or one of the main ideas in this lesson, is that you can use inductive reasoning to go from a particular set of observations like a table to a general rule, which you can express in words or in an equation in different ways. So let's get started with some practice using that vocabulary. Let's use the table at the right for exercises 2 through 4. That's this table over here. So we're going to complete each statement with one of these words: add, inductive reasoning, multiply, pattern, or subtract. So question 2, to find the value of item number 5, that's this square here that's missing. To find that value, what can we do? Well, we can look for a pattern. What's the pattern in the way the numbers are going? So it's obvious what the pattern is in the first column, 1, 2, 3, 4, 5, but what's the pattern in the second column? Well, really, that's the answer to question number 3. That's the same thing question number 3 is asking. To obtain the value for an item, like number 5, how do you get the answer? This one might be a little hard to see at first. This one looks like nothing happened. But if you did 1 times 1, you would still get 1. If you did 2 times 2, you would get 4. If you did 3 times 3, you would get 9. And 4 times 4 would give you 16. So it makes sense that 5 times 5 would be 25, and that's the missing number. Now, the question didn't ask us for that missing number. It said to obtain the value for an item, you can blank the item number by itself. Well, we can multiply it by itself. So multiply is the missing number. And what was the concept we used to get that? Well, that's inductive reasoning. Question 4, you can use inductive reasoning to predict the value of the item number 5. Now we're going to work on identifying solutions of a two-variable equation. So questions are going to be in this form. Is the ordered pair, in this case 5, 20, is that a solution of the equation y equals 4x? So here's a little plan for thinking it through. In 5, 20, we need to identify the x-coordinate and the y-coordinate so we know where the numbers go in the equation. So the x-coordinate is the first number, 5, and the y-coordinate is the second number, 20. If you're ever confused, just go alphabetic order. X comes first, so the first number is x. Now we can substitute 5 in the place of x and 20 in the place of y. So this blue y gets replaced with 20, and the red x gets replaced with 5. Now we can simplify the equation. The left-hand side doesn't need any simplifying, it's just 20, but the right-hand side says 4 times 5, that's also 20. So now we just have to ask ourselves, did it work? Does 20 equal 20? Yes. So is 5 comma 20 a solution of y equals 4x? The answer is yes. So you want to circle yes in number 6. In problem 2, we're going to practice using a table, an equation, and a graph. So here's a question. Will runs 6 laps before Megan joins him at the track. They then run together at the same pace. How can you represent the relationship between the number of laps Will runs and the number of laps Megan runs in different ways? We're going to use a table, an equation, and a graph. So in number 7, we're supposed to complete the table. So the first row shows the number of laps that Megan runs, and the second row shows the number of laps that Will runs. In the first row, it shows that when Megan runs 0 laps, the number below that shows that Will runs 6 laps. That's consistent with the first sentence. Will runs 6 laps before Megan joins him at the track. So he has already run 6 laps before she even starts. That's kind of what those two numbers mean. So after Megan has run 1 lap, how many laps will Will have run? Well, he's already run 6 before she got there. Then they ran this 1 lap together, so he will have run 7 laps. Now, we have the opportunity to write whatever numbers we want up in that top row for the number of laps that Megan runs, but it kind of makes sense we should just go in order. 0, 1, 2, 3, 4, 5, 6, 7. So now we need to figure out how many laps Will runs for each of those. Pause the video for a moment, fill in what you think those numbers are, and then join me back again when you have those numbers ready. Welcome back. Hopefully you realized that Will always runs 6 laps more than Megan, since he has run 6 laps before she gets there. So if she has run 2 laps, he will have run 8, and all of the other numbers will have run 6 more than Megan. So that kind of helps us answer question number 8. If we circle that relationship, which one is the right description? Well, the last one. Will runs 6 more laps than Megan every time. So we want to circle that last pair, or that last statement. All right, let's look at questions 9 to 11. If we let x represent the number of laps that Megan runs, then what would y represent? Well, that makes sense. It would be the number of laps that Will runs then. So now we want to underline the correct word to complete the sentence. In this relationship between the number of laps that Megan runs and the number of laps that Will runs, y, that's the number of laps that Will runs, will always be greater than or less than x, which is the number of laps that Megan runs. Well, since Will started running first, then the number of laps that he runs will always be greater than the number of laps that she runs. Now we're ready to write the equation. So if we start with y equals, how does that compare to x? Well, y equals x means they both run the same number of laps. That's not true. Will always runs 6 more laps than Megan does. So y has to always equal x plus 6 more. Exercises 12 to 14, we're going to be working on a graph of the relationship we just looked at. The ordered pair that corresponds to Megan arriving at the track is the first ordered pair we had, 0, 6. It says in number 13 to use the table in exercise 7, but I think we understand the relationship enough that we don't have to look at the table. If Megan runs 2 laps, Will run 8, because he always runs 6 more. So if Will has run 10, then Megan would have to run 4, because she runs 6 less. And in the last one, we can fill in any ordered pair that we want. We can use one from the table or something new. I'd like to propose that we think about, what if Megan has run 12 laps? How many laps will Will have run? Well, he always runs 6 more, so it will be 18. The y number is always the x number plus 6. Last question here, number 14, says graph the ordered pairs, and then connect the points, and be sure to label the axes. So pause the video for a minute or two to do that, and then turn it back on when you're ready to see how you did. Welcome back. So, how did you do? Do you have the right graph? Did you remember to label the axes? Moving on to problem number 3. We're going to use the figure below. It doesn't really say so very clearly here, but this is figure number 1. This is figure number 2, and this is all figure number 3. So we're going to use that to complete the table in number 15. So in figure number 1, there are 4 black tiles. You can see them here. 1, 2, 3, 4. So there's 4 black tiles in figure number 1. How many total tiles are there in figure number 1? Well, there are 3 rows of 3 tiles there. So there's 9 tiles altogether in figure 1. In figure 2, how many black tiles are there? Well, now we can see there's 4 on the top row, 4 on the bottom row, so there's 8 black tiles. How many tiles total? Well, now there are 6 columns of 3 tiles, or 3 rows of 6 tiles, so there are 18 tiles altogether. And in the third row, or in figure 3, how many black tiles are there? Well, there are 2, 4, 6 across the top, and 6 across the bottom. That's a total of 12 black tiles. And how many tiles are there total? Well, essentially there are 3 tiles that look just like the first one. So there are 3 times 9, or 27 tiles altogether. Or you could say there's 9 columns of 3 tiles, or 3 rows of 9 tiles. In question 16, for each new figure, how does the total number of tiles change? So really we're looking at this. How does the total number of tiles change as we move down from one figure to the next? So figure 1 had 9 and figure 2 had 18. It looks like we added 9 tiles. And then figure 2 had 18, figure 3 had 27. Again, we've added 9 tiles. So that looks like choice D in this list. It increases by 9. In number 17, a figure with 24 black tiles will have how many total tiles? Well, it would be really awkward if we had to draw a figure that had 24 black tiles. So let's see if we can make a prediction based on the pattern that we have here. Why don't you go ahead and think about that, pause the video, turn it back on when you've got an answer, and see how you did. Welcome back. I hope you were able to figure out that a figure with 24 black tiles will have 54 total tiles. One simple way of reasoning that out is, if you look at figure 1, that's a single tile. It has 4 black tiles. So if you put 6 of those together, then you would have 6 times 9, or 54 total tiles. Next up, you've got the got it. Make a table showing the number of light gray tiles and the number of white tiles in each figure. How many white tiles will be in a figure with 24 light gray tiles? So I'd like to suggest setting up a table something like this. Let the first column represent the number of light gray tiles, and the second column of your chart represent the number of white tiles. And then count the number of light gray tiles in each figure, count the number of white tiles in each figure, and then see if you can make a prediction for how many white tiles there will be in a figure with 24 light gray tiles. Pause the video, think about that, figure it out, and when you're ready, turn it back on to see how you did. Welcome back. I made a table that shows 1, 2, and 3 because those are the figures that I have. I counted the number of white tiles in each of those. I hope you agree with those numbers. And then to represent the question, if the number of light gray tiles is 24, how many white tiles will there be? And the correct answer is 48. Go ahead and work on the rest of your notes here. Pause the video, spend some time on that, and when you're ready, come back and I'll show you what the solutions are and you can check your answers. Welcome back. Here are the answers to 18, 19, 20, and 21. Take a few seconds to scan over those answers. If there's anything confusing for you, remember to ask about it when you get a chance in class. For the lesson check, for question number 22, all of these points are solutions of the equation. So in exercise 22, each value of y is greater than, it's 2 greater than to be specific, it's 2 greater than each value of x. So describe the pattern in the solutions. Basically, you want to say something like each y value is 2 greater than the x value. Thank you very much for listening to this lesson. Good luck. Remember, do your best. Forget the rest. Bye for now.